Hey everybody, Adam with FANUC here. Today we're gonna cover a pretty handy topic of handshaking your robot with some kind of peripheral device. This is extremely common, when it's not just the robot in a system. You've got a PLC you're talking to, a PC, maybe even something like a gripper or an intelligent valve bank, field IO. Sometimes that robot just needs to send some status bits back and forth. What this video will not cover is how to set up the communication between your robot and your thing, whatever that thing might be. So whether it's Ethernet IP, Profinet, Modbus TCP, OPC server and client, whatever your flavor of choice is for talking to a thing, that's not what I'm going to cover. What I am going to cover is the code behind it, what you would actually do on the teach pendant on that front end. So let's dive in a little bit. Before I show you how to custom make some handshakes and IOs, I want to show you what FANUC gives you right out of the box, which is super handy stuff. So you're going to start by opening your I/O tab. You're going to hit the button on your teach pendant or tablet to get in here. Now, if you hit the type key, the F1 key, and you look around, we've got a lot of stuff going on in there. We've got cell interface, custom, digital I/O, blah, 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 blah. I'm not going to hit every single topic on this video. If there's more we need to talk about, drop me a comment and I will. But I am going to hit some of the important ones. Off the bat, some very important stuff that you might want to know about the robot is in our UOPs. We call it the UOP, the User Operator Panel. It's basically a virtual operator panel, right? So way back in the day, everything was buttons and knobs. These would be indicator lights on your controller, but now they're bits. If you look at the UOP outputs, we got user outputs, toggle that, user inputs. So inputs are things that you can send to the robot. Things like a hold signal, a safe speed signal, cycle stop, fault reset, start, go home, enable. And you've probably recognized some of these from my other videos where we have program number select and run service request and all these fun things. So these are basic handshakes that you should be, and by the way, this top one is immediate stop. These are things that you should be sending to your robot when you want to reset or start. Things the robot might send back to you. Command enabled, systems ready, programs running, program paused, blah, 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 blah. So these are things that you can map by going to your config, and you can map them to your rack and slot of choice. You'll see in other videos that rack 89 is your Ethernet. I think rack 48 is your I/O card. Just map it and use it, right? So map it and use it. They're there. Other fun stuff, right? We have the standard operator panel, the SOPs, which is things like, hey, you have a battery alarm and I am held and blah, blah, blah. Is the teach pendant enabled? Let's test it. Oh, teach pendant off, teach pendant on. You can send that kind of stuff to a PLC. From a PLC, again, hold, fault reset, cycle start, all that stuff. All right, you probably knew that existed, so let's get into some cooler stuff. Let's look at the cell interface. This is a really important section that is highly underutilized. I don't know why more people aren't using this. These are default things that FANUC figures you might want to know if you're a PLC. Things like, hey, is someone simulating my I/O? Yes or no, right? If someone has their I/O in the robot being simulated, that means the PLC no longer has control over the I/O. So you might be telling the robot to do something, it's not doing it because someone's debugging and forgot to quit debugging. You might want to know that stuff. You might want to know if your robot is running at 100% or Or if someone slowed it down to do some testing and then forgot to turn it back up and you're losing production. You might want to know if you're in cycle, blah, blah, blah. Heartbeat, those are good things to have. So let me show you a little how these work. Then after I show you how these work, I'll show you how to make some of your own. So let's rock and roll a little bit. So first and foremost, let's set up one of the, hey, IOs are being simulated. So let's say I want to know if I am blocking an input from the PLC to the robot would be an input. I'm going to go to my config, and I'm just going to say, you know what? DO number 5. Why not? Verify it. Yep, port assignment is valid. This is checking that DO5 is available and not currently mapped to something else. So yep, I can let that be DO5. Cool. Notice the love note that you get. Power off and then on to enable your changes. So as we're dialing these things in, we're going to have to cycle power. Let's also enable this guy. I want to know if my robot's running at full tilt or if it's being lazy today. DO6, verify, valid. And then let's do a heartbeat. Let's give this guy a heartbeat at DO7, verify it, life is good, previous. All right, so I've mapped a couple of these. You see my heartbeat is already working. It's alive. The heartbeat's already working, but we got to power off and on to enable changes. So let's do that. I want to cycle power. Y'all didn't see that on the screen, but I hit the little swirly key and then said cycle power. While this is cycling power, and hopefully my screens come back and behave the way they should. I've had my screen recorder jumble on me a couple times. If it jumbles, I promise to fix it. And oh yeah, she jumbled. Bear with me, guys. I'm gonna fix this. Hold on. Bum 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 bum. And there we go. All right, sorry about that, guys. Sometimes the screen jumps when I cycle power. All right, so we've cycled power. Let's dive back in. All right, I can see right here that the override 100, that signal is on right now. So if I slow this robot down, look at that. Signal goes off. Go back up to 100%, signal goes on. I see the heartbeat humming along. We'll play with this in a second. Let's go ahead and look at what the actual outputs look like, because that's the important part. Is the cell interface is sending this stuff to your PLC or your HMI or whatever, so that y'all know what's going on. So let's go digital output. Here's my DO screen. Look at how cool is this, guys? By the way, I did not put these comments in. FANUC did that for me. As soon as I verified it and cycled power, it dropped in saying that DO5 is my input simulated bit. DO6 is my override 100, which goes away if I'm not at full speed. DO7 is my heartbeat. So every 1 second, your PLC should see an on-off-on transition to know that you're talking, so you don't have legacy bits. Let's test our other one, the input simulated. I'm going to triple my display. All right, so I've got this guy here, my DOs there that are telling my PLC what's going on in the world. Now down here, I'll go to my digital inputs. So digital inputs, maybe that's, I don't know, a box presence sensor, right? We're over here and someone's testing if your new scanner is working or that the bull feeder's on or whatever. If I'm debugging and I simulate a sensor and forget to turn it off, kabam. Look at that. Regardless of the status of the bit, doesn't matter if I have it simulated on or off. See that? It doesn't matter if I'm actually simulating it or not. The fact that I have control over that input rather than a sensor having control over that input, that's enough to trigger the cell IO, which is enough to tell the PLC or the HMI to tell you something's going on. Y'all might want to go in here and fix this. And that's when you can come back down here and say unsimulate. That bit goes away. And now you know that all of your IOs are valid and life is good. So please, right off the bat, Leverage these guys. They're helpful, they're great. Of course, robot motion means, is the robot moving? I've actually got a video on that, but here's one that you can set up in 2 seconds. That's awesome, right? Cool. What if you want to make your own? You want to make something, let's make a program first. Let's just call it Adam. That's so original, right? Let's make a program here, and let's say that we have a basic handshake. Something like, I am going to turn on a vacuum, and then I want to make sure that I got vacuum at my end effector before moving the robot. So you might start with something like, hey, I move into position, and then I need to turn on a vacuum. So let's say IO, maybe robot output number 1 has to turn on. Now what you can do here, this is one way to do this. This is a very simple back check, is you can just do a wait. So this is the first and easiest thing you can do, is a wait statement that looks for either a digital input or a robot input. Typically your grippers are wired to your robot inputs at your EE connector. So I'm going to turn robot output 1 on, and I'm going to wait until robot input 1 comes on before I go back to moving and doing other fun stuff in the world. And so what's going to happen in this chunk of code is you move down to a part, you say I'm trying to pick up the part, and if you don't pick up the part, you'll get hung up at line 3. And in fact, the default system variable timer on a wait statement is 30 seconds. You can change that in the system variables. But if this robot gets hung up at a wait statement for more than 30 seconds, it'll just pop an alarm, and it'll say, hey, the program timed out at program Adam line 3. And you're like, oh yeah, my vacuum's not working. So that's one thing you can do, just as a bare bones, like that's as easy as it gets, handshake. But what if I need to talk to a PLC and actually have an acknowledgement command to call a program? So let me get rid of a couple of these lines, delete. Let me insert a few lines. Okay, so I'm running along, life is good. And then I need to get some direction from a PLC. I want to know that it's time to turn a pump on, or it's time to go pick a part. This is where our if statements come into play. And we have a lot of them, guys. There's a lot of different ways that you can start with these conditional statements. We can do if equals, if not equal, if less than or equal, greater than or equal. This one's fun because it kind of lets me roll my own. Then of course we have if then statements, and then if then, and then of course else and end if. So let's play with just a couple of these real quick. When you use this first option, you're a little limited because it pre-builds some stuff for you. Watch when I insert this. I'm going to click that, and actually let me just get out of here real quick. When I click that, it plunks this information down. If blank equals blank, do blank. Well, if I jump into this, let's just say if digital input 1 comes on, this is all I get to do. These are your options. I can either jump to a different part in the program, call a program, or call a program with an argument, or I can actually compound my conditions where I say if digital input 1 is on and digital input 12 is on. So if they're both on, call a program. I can't call well, don't call your own program. But that's what this first if statement is. When you look at this first if statement, it's just pre-built goodies that if something, call something. So that one is a real quick conditional to call a program. Maybe you're sitting in a main loop and you got to wait for something to come on to jump out of that loop and go somewhere else. That's a good one. Let's show you the other if statements where you can get a little more creative. So this if statement, let's plunk this one in here. If digital input 1, see how it didn't pre-build anything for me? It's just sitting there. I have to build my own. And when I go to build my own, now I have even more choices. I can do some basic math, addition, subtraction, divide, mod, equal to, less than, whatever. Let's just say, where am I in this one? If digital input 1, untaught, equals on. Now let's see what I got in here. I have a couple more options. I've got the calls and the jumps, but I can also do some other logic where I can do things like pulse a bit, like that. Oh, that's the wrong, oh man, I already mapped that guy. There we go. So if digital input 1 comes on, so the robot reads a value, I am going to pulse digital output 9. So that's just, I got a signal, I'm sending you a signal back. That pulse, I'll be honest, I'm not sure how long it lasts. I think it's a couple scans. It's like, the ITP scan rate of a robot is 8 milliseconds. So it might only be on for one scan. So you got 8 milliseconds to catch it. If you're in PLC land, you're scanning in microseconds, so that's not a problem. But it will set DO9 high for one scan or for a short pulse time, and then just automatically turn it off. So that's cool. That's just a real quick way to acknowledge things, that if something comes on, talk back. Or we can take this a little bit farther. If we want it to be a longer pulse or a different type of response, we can use this one, the if-then. So if digital input 1 insert equals, if it equals on, okay, so DI1 comes on, then whatever I put in here, it can be motion programs where I go and do something. It can be wait statements. I'm gonna wait. I can do whatever I want, all the way until I get to the end if statement. So what I'm doing is I'm encapsulating from an if to an end if. I've got if this condition, then do this, and if. And they're married together. So let's say I've got if digital input 1 comes on and I want to respond back. Well, let's respond back with DO number 9. I'm going to turn it on, leave it on for 2 seconds, and then go back up here, do a little copy, select, copy, do a little paste action, get rid of the dead zone here. So turn it on, wait 2 seconds, turn it off, right? So now I've done the same thing as generating a pulse, but now I control that pulse with this. In fact, I could even change that to be an indirect address and say, hey, whatever's in register 5, go look at register 5, call that my pulse width, and I can make those changes on the fly and make my pulse be whatever I want it to be. So that would be 1 second or 2 seconds or whatever it's going to be. So that's another way of doing this, right? Is look, react, wait, turn it off, do a little handshake. Let's see here. There is also, which one else did I glance over? I've done a video on the select. That's for program calls. Check that out. Else statements, right? So if we want to do an else, oh, look at, by the way, it's always fun to get love notes from FANUC. You need your if for an else. You can see I put the else outside of my logic, and it's letting me know that. So let's just go ahead and do a little select, cut, go down here, paste, logic. There we go. Happy robot, happy life. So what we can say is, if digital 1 comes on, then we're going to hit DO9. I'm going to just put this back as seconds so you all see what's going on. DO9 comes on for 2 seconds and turns off. Else, meaning if DO1 is not on, Else, maybe we tell the PLC something else. Else, let's turn something else on. I don't know. Or we can set a group output or do something fun. Group output, maybe it's a status bit. Status bit goes to a 5. I don't know. But it could be some other form of communication. It could be another output. Digital output 10 is on. So we could say, so you can see how we can build some basic handshaking logic back and forth based on what we get in, talk back, turn things on and off. The last bit, I think that is, oh yeah, sorry. So the very last bit I want to talk about is that things do not have to always just be on and off. We can certainly do analog, meaning numerical. So let me delete these lines. Here's my end if. Let's say let's make this be, instead of a digital input, let's let it be a register. If register 10, and then make it be, if register 10 becomes greater than, and let's just do, you can set it as a constant. If it becomes greater than 50, then tell the PLC that your counter is up. Tell the PLC DO99 turns on. So maybe you have a part counter where we're deburring parts, and every 50 parts you need to change the tool bit. Well, the robot can be doing the counting, and as soon as you hit this threshold, running, it just turns that bit on. And then you'll have some logic, of course, down here that a user changes out the bit, resets the counter, and then DO99, you'll turn that back off. But these are the types of handshakes that you can build with your HMI, with your PLC, with your industrial PC. Things to let operators know what's going on. Things to let equipment run and talk to each other. So, guys, I threw a lot of information at you in these last 20 minutes. I like to keep these videos short, so I'm just torrenting it down on you. I really hope this helps. If you want to learn more on this, let me know in the comments. We can take a deeper dive on any of these subjects. If you got other topics you want me to talk about, throw them at me. I've got a good list being queued up. As always, I hope these really help you guys. Thank you for watching, and please have fun coding.